Okay, friends, good evening. We welcome you all to this Let's See program. So, this is a C language free training course. So, we welcome you all to this special class. Today, we are going to hear second class. Already, class one last week is done. So, that in our YouTube channel it is available. Kindly check it and refer to it. And today, our instructor Ramakrishna.M is available. So let's invite our instructor and hear the class from him. Okay, sir, now you can take the class. Thank you.
Thank you. Welcome to Let's See class, the second class that we have today. So in the last class, what we have learned, I think we learned many things. So first of all, we saw the history of C, and later we went ahead and write some sample programs. So initially the printing some statements on the console that we wrote, and next level we went for doing some arithmetic operations, writing code to do some arithmetic operations, especially finding area of a square and circumference of a square. From there we came to write functions. Okay, and yeah, so from there we wrote functions, and we briefly learned about the structure of C program, right? The structure of C program, and about we saw about main function, right? From where the execution starts for C. Yeah, so those things, and especially in the first class, right? So we looked at the compilation steps, right? So we looked at the compilation steps. So if any of you remember compilation steps, can you briefly just put them in the chat? Yeah, compilation steps. What are the 4 compilation steps that we have? What are the 4 compilation steps we have? Yeah, anybody? Can just put them in the chat. So there are 4 compilation steps. You can put them in the chat. So this is the only question that I want to ask you. I won't ask you any other questions. Okay. Yeah. What are the 4 compilation steps that we have? Okay, fine. Yeah. Let me show you that from the last class. Okay. Right. So these are the 4 compilation steps. Okay. These are the 4 compilation steps. So the first one is pre-processing, right? The first one is pre-processing. So in the preprocessor, what happens? Okay, preprocessor, what happens? All your macros and include statements, right? They include hash include statements. They will be expanded. Okay, they will be expanded, and your C source file grows. C source file grows. Okay. And next thing is compilation. Okay, so pre-processing is done, and next step is compilation. So in the compilation, what happens? In the compilation, the C code, the expanded C code, the complete C code, pre-processed C code will be converted into assembly code. Okay, and that assembly code will be given to the next stage called assembler. Next step called assembler. So this assembler, what it does is, from assembly language, it converts to machine code, which can be understood by the processor itself. Only processor can understand. So it's all zeros and ones. You cannot understand that. So till assembly program, you can understand a little bit. So assembly program, there are assembly programmers also. They can do assembly programming. So when we don't have this C and all, so we relied on writing C assembly programs. So when you come to engineering, right? So in third year or somewhere, You'll write some assembly programs using a turbo assembler and MS-DOS assembler. Using those assemblers, you write some programs, basic programs like, excuse me, basic programs you'll write in assembly language. So assembly program also you can understand. So after assembly program, after assembly step, assembler what it does, so it will convert the assembly program into the machine code, okay, zeros and ones, and that is object code we call. That is we call object code. So that object code you cannot understand, only computer can understand. So that object code still not complete. So there is a last stage called linker. Last stage called linker. So what we do in the linker? So in the object code, there are references to some other libraries. Okay, there are references to some other libraries. In our previous example, we have seen printf, right? Printf. So there is a printf statement we used to write the text on the console, on the monitor. Okay. So printf, who define, where is printf? Okay. So that printf code will be linked here. In the linker, the printf code will be linked. Not only printf code, but whatever the libraries you used, then all those references, all those definitions will be linked to the actual to this object code, and it will create a binary finally. Okay, so you can write your own library that also will be linked by the linker. Okay. So this is how the 4 stages of compilation is. Okay. So when you invoke compilation, when you invoke compilation for a given source file, given C file, then it will flow through these 4 steps. These 4 steps, right? Yeah. So next, what we have seen, we have written hello learners program, right? We have written hello learners program. So while looking at the compilation steps, we have seen, writing a hello learners program. Okay, I showed you. Excuse me. So I showed you, right, how preprocessor step works and how compiler works, and how assembler works. All those steps I told you while writing this hello learners program. And now we have briefly saw what is the structure of a C program. So structure of a C program is, first what we will write. We write comments, right? We write comments. So those comments are for what? To tell that what is your program doing. Okay, to tell that what your program is doing. So in case of circle, area of a circle, so we have written area of a circle, right? So what are the comments there? This program finds the area of a circle. Means that briefly what it does, what this program does, we'll write at the comments. So that is required. So if you see some examples, some open source examples or open source C code that is available today, so they will write many things there. Okay, so what this software does, and who owns the software, and license to the software, and when this published, when this is written. So all those things they will write. Okay, so that is the importance of comments. Comments gives you the first comments actually. So the comments gives you what this program will do in high level. Okay, so that is required. So you can have single line comments or multi-line comments. Okay, single line comments you will represent by double forward slashes, and multi-line with this forward slash and asterisk, and at the same time the vice versa will use to close the comments. Okay, right. So next in the C program, so what we will add, the includes, right? In case of our first program, hello learners program, what we have written, hash include stdio.h, hash include stdio.h, which means that we are including standard input output header file. Okay, standard input and output header file hash include um, corner braces or angular braces stdio.h, which means that we are using stdio.h declarations or definitions inside our program. Okay, so here in this place, right, so not only hash include, after this we can have macros. Okay, hash define some macro and blah blah blah, so and function declarations, so all those things we can have. And next thing is function prototypes and variable declarations. Okay, so function prototypes means in our program, if you want to use some functions, if you want to use functions, then we will write our own function. So for those functions, we need to have the declarations or prototypes. Okay, and if we have global variables, then we will declare global variables in this space. Okay, and so after that we have main function. So main function is where our whole our C program starts, execution starts basically. Okay, and we have our definition of the function. Okay, so this is how to write a C program. So I just want to reiterate on this thing. So this is how to write a C program. Okay, right. So yeah, so we briefly discussed about header files and other stuff. Yeah, Abhishek asked me one question. Is there any problem if we do not include comments in our code? There is no problem at all. The comments will not be compiled. The comments will not be compiled. Okay. So if you provide comments like this is not part of the code actually. So this will not be taken into consideration while compilation. This will be ignored. This portion will be ignored. So there is no harm in not having comments, but the best practice is to write comments so that everybody knows what this program does. Everybody knows what this program does. Okay, right. So this is we have seen header files and some other stuff. And now we have seen the arithmetic operations, what are allowed in the arithmetic operations and expressions. So this stuff we have seen, and we have seen area of a circle. So I just want to start take a look at this circle area of a circle program. Okay. Yeah. Okay, so last time we have written this program. We have written this program to find the area of a circle, right? Right. So last time where we stopped, so we stopped after writing a function to find the area of a circle. Okay. So let's see. Let's continue from here. So I just want to explain this one more time to you. Now, these are the comments and this is the includes and this is the function prototype. So this is the function prototype, which is here, which has definition here. Okay. So this is the function prototype. Function prototype means we are simply telling to the compiler that, I have a function. The definition is not here. So whenever you see this thing, whenever you see this word or maybe this statement, you think that the function is already defined somewhere. Okay, you think that The function is defined somewhere, and don't error out in the compilation. Don't error out in the compilation. So the function prototype does this job. Okay, right. And here this is the main function. So where the program starts executing, and so inside this one we have called area of a circle, and then we are sending the radius to this function. And now this is the definition of area of a circle. So we are calculating the area here, and then returning the value to the caller, returning the value to the caller. And at the end, at the line number 23, what we are doing, we are printing the area. We are printing the area. Okay. So last time I told you that there is a problem. There is a problem in this. Not a problem, but it is not optimized code. Okay, it is not optimized code. See here. So here only area of a circle we are finding. For example, I want to find circumference of a circle. Then what I do? First, I need to write the write its prototype. Right? Write its prototype. Circumference of a circle. Okay, right. I'm sending radius. I'm sending radius to it. So here, this is the prototype. This is the prototype. So this returns float value like the area, and it takes a radius, which is an integer. Okay, which is an integer. This is the function prototype for the circumference of a circle. And now I want to get the circumference value. So I will call this circumference of a circle function, and then I'll pass the same radius. Okay, I'll pass the same radius. Now here I have declared this function and I have called this function, right? But where is the definition? So if we call this function, there should be some action, right? Circumference need to be found. So we need to define this function. We need to define this function. So I will write the definition here. The definition here. Okay, similarly like the area of a circle. So my circumference is float value. Float value means a decimal value. It can represent decimal value. So more about data types we can discuss later as going forward. Okay, so integer can only store things that are of integer types. So it cannot store decimal values and all. Float and double can store those decimal values. Okay, so float circumference, because our circumference is a float value, because in the circumference formula we have pi, right? Pi, nothing but 3.14. So there is a big number, that is, so there are many decimal values after the decimal point, but we don't consider basically only the two very next decimal places will be considered for calculating for any formula. Okay, so 3.14 basically they use. That's why the circumference of a circle is actually a float value, a float type. And now what we need? So float pi, and what is the pi value? 3.14. And what we are doing here? So we are finding the circumference. We are finding the circumference. What is the formula? 2 pi r. 2 pi r radius, and I am returning this value. I am returning the circumference back to the back to my caller. So here at the line number 23, my main is calling circumference of a circle. And so once all these comments, then the flow comes here. When line number 23 executes, then the execution flow comes to line number 41. Line number 41, and it starts executing all these statements. And once line number 46 is encountered, then the control goes back to main again. The control goes back to the caller. Okay, right. So here, once you find this circumference, then we need to show it. We need to display it on the console. So here I had a printf statement. Right. Then here there is an error because we have not defined, we have not declared CF. Okay, we have not declared CF. So just uncomment these lines. Okay, now go back and compile. GCC circle.c and our executable name. Okay, sorry, I think the name I have given wrong. So let's see, I will tell you how to interpret the errors also here. Okay, see here, you have seen some error red marks, right? So these red marks represents error. Okay, and you can get it from the text also, that when there is a error is displayed on the target, which means that there is error in the program. Okay, and see here, this is the file name where the error is appeared, where the error is there occurred. Okay, so in complex softwares, right, there are many source files. Here circle.c, but there can be rectangle.c, there can be square.c. So in some file there can be a error. So here circle.c, and now at line number 23 column 30, line number 23 and column 30, there is an error. And read the error. RAIUS undeclared. Undeclared means you have not declared this variable, but you want to use it. Okay, you have not declared this variable, you want to use it. So so it is asking us to declare it. Okay, and the next statement is intelligently it is asking, by chance did you mean radius, or maybe did you forget, or did you forget the forget that forget the name of already existing variable? So it is telling you intelligently. Then you can easily understand. So what is the problem there? So the problem there is the RAIUS is not declared. Okay, RAIUS not declared. Basically radius, right? Radius. So I did not type it properly. Radius, RADIUS, radius. So D I missed, and then it is complaining about this is not declared in the program. So go back and see at line number 23, right? At line number 23. And this is RAIUS. So radius. Okay. Then now it won't complain now. See, it won't complain now. Right. So it has created a executable called circle. Let's run this thing. Yeah. See the area of a circle, this one, and the circumference of a circle, this one. Okay. Yeah, we have found the area and circumference of circle. Yeah, let's see here. So we are using 3.14 in this function, and also we are using 3.14 in this function. Do you think that can this be changed? Do you think is there any thing we can do here? Because we are using already, reusing the thing again and again. So repetition is there. So here 3.14 is there, and here 3.14 is there. Okay, right? And in future, if there is some other thing that involves pi, okay, this is pi value, right? If there is any other formula that involves pi, then there also we need to use these two lines to represent pi, or maybe we can directly write 3.14 here. Okay, I mean 3.14 is keep repeating in all your functions, or maybe in many parts of the code. Okay, so which is not which does not look good, and which is not good for readability, all those stuff, right? Which is not optimized also, because here you are using float, right? Float takes a considerable amount of memory in your RAM. Okay, and you don't for example, if you are working on some systems where low memory is low memory it may have. So in those cases, what you do, so you will try looking for optimizations, right? You'll try reducing the uh, reducing space and all those stuff. Okay, so here how you can overcome this problem, like there is 2 times here pi has appeared, 3.14 has appeared, then how can you overcome this problem? So the best thing that you can do here is by using macros. So macros can be defined using hash define. Macros can be defined using hash define, and I am defining it here 3.14 hash define pi 3.14. So now I have defined a macro which is pi, nothing but you can think of like a constant. Okay, constant. I can use this pi in my code. Okay, in my code. Let's see. So I don't need these two lines anymore. So what I will do here, just put pi. Line number 39, I just put pi. Okay, and here these two lines also I don't need here. So I'll just put that constant pi. Okay, so let's build and see whether it works or not. Okay, GCC or compiler and source file and -o. -o means it basically the executable name, and also it include all the steps to your compilation, and your executable name, -o executable name. So now we didn't see any compilation issues. Okay, now it has created a circle at 25, means 85. Okay, 85. So now the time is 85. Just now it got compiled. Let's run this. Okay, now there is no issue. Let's see whether the result is same with the previous one or not. See here, the result is same without macro and with macro. Okay, and now see the compactness. Okay, see the compactness, right? See the compactness and readability of the code here. So we have added pi here, For example, tomorrow we are using only 2 decimals, right? I want to use few more decimals here. So the pi has some more, right? 3.1411 something, right? So if I want to change this one to 3.141, then during the compilation, everything will takes the new thing. I mean, new value here, 3.141. So by changing at one place where the references to this particular macro, in everywhere it will change. Okay, so there is a greater advantage of this of these macros. Okay, and how it will work, Okay, that is a interesting thing, right? How it will work. So see here, you have defined this pi as 3.14. So it looks for pi in your code. So and what is this one? What is this one? This is a preprocessor directive. Hash is preprocessor directive, and hash define is preprocessor function. You can think of like that. Okay. And what it does, so this will be expanded during the preprocessor step in your compilation, preprocessing step in your compilation. So here in the line number 37, at line number 37, the pi will be replaced with 3.14. The pi will be replaced with 3.14. And at line number 44 also, pi will be replaced with 3.14. Okay, I'll show you that. So what we should use to just create preprocessor output? What we should use? What is the flag we should use? ext.c. Okay, right. So we have created preprocessed C file. Preprocessed C file. Let's open it. Let's open it. Yeah. Let's go to our portion. So this is hash include and all the stuff. Let's go to our portions. Okay. So here, from here, right? Int main and all this. This is our actual code that we have written, a handwritten code. Remaining all, hash include std has, that is expanded. Okay. Right. So come here, area of a circle. So here you have pi. Here you have pi. See here, line number 37, you have pi, capital pi, but here it is 3.14. 3.14. And here line number 770 also, we have 2 pi r, and the pi is replaced with 3.14. 3.14. Here pi, and here there is no pi. So in the preprocessed C file, the macros are expanded. The macros are expanded, which means that, whatever you have defined, all those are expanded. All those are replaced or substituted. Okay, good. So just want to show you. Yeah, preprocessor macros. Just want to show you the preprocessor macros, the use of preprocessor macros. See here, so in our preprocessor macros, what we have encountered till now, hash include stdio.h, that expands the header files, that expands the header files. Here stdio.h, and we can define constants. So hash define pi 3.14. If you put hash define pi 3.14, then pi will be replaced with 3.14 in your preprocessed C code. Okay, throughout the source file, whenever there is a reference to pi, then that will be replaced with 3.14. So consequently, what you can do is you can write functions in preprocessor macros also. You can write functions in preprocessor macros also. So here you can define function in the macro itself. See here an example. Okay, hash define add to x comma y and x plus y. Okay, so what this will do is this will add two variables x and y. Okay, so tell me one thing, what it does. Whenever this preprocessor sees add to x comma y, or add to some value, let's say 5 comma 6 or some values, then it will replace the entire string with this statement. That is the only thing it knows. Okay, that is the only thing it knows. It is not like our regular functions. It just replaces code. Okay, And in our C++, right, we have inline functions. We have inline functions. If you write inline, then that code, the entire code will be substituted in those places. Whenever that function is there, the entire code will be substituted. Okay, inline functions in C++, but the same thing is available in C as macros. Okay, there are many differences, but I'm not going to take. But if you take the behavior, then they will be same. Okay, right. Yeah. So preprocessor macros, not only we have seen only define, right? So not only define, there are many other things. There are many other things. So there is a condition, hash if define, hash if end if, hash else, hash elif, and hash end if. Okay, there are many things. So I have not completed taking the control statement set, if else, and some other control statement set. When you have that knowledge, then you'll understand if and if def. You'll understand those things, but I'll explain them now, and you'll understand when we are touching upon those control statements. You will fully understand what they do and all those stuff. Okay. Yeah. So there are many other preprocessor macros we can use to control what code needs to be included in the compiled output object code. So we can the beauty of the macros is that during the compilation itself you can select what code needs to be there in your object file. Okay. Let's say that hash if one, let's say hash if one, hash include std.ioh and hash else something else. Okay, right? Or hash if some condition and then your logic, and hash else some logic. Then that if statement is fulfilled, then only those lines will be added into your code. Otherwise the else part of the code will be added. So I think it looks like it is in the air to you, but I'll explain clearly while writing the code. Okay, so you just, for now, you just think about preprocessor directory is not only hash include, hash define. There are many other things. Okay, hash if def, hash if end if, hash else, hash elif, and hash end if. Okay, hash end if and hash if goes together. Hash if define also goes together, and hash else also you can use if you want to have two branches. Okay, so there are things there. Okay, and and also in your code, okay, I told you, right, the flow can be the code can be um, taken into compiler output based upon the preprocessor macros, this ashif and these things, right? So there you can give an input from the command line, from the compiler command directly. Okay, from the compiler command directly. So while you are compiling the command, you can give a value to a macro inside the code. So by using hyphen dname equal to value, hyphen dname equal to value. So name is the macro, in your code. So you can define that, or you can define that during the compiler command. So using something like this. So let me just tell you that. Okay, right. So you have defined pi here, but you can send pi value from command line directly. Okay, from command line directly. Okay, so what you can do is, so you are compiling here, right? You are compiling here. So what you can do is hyphen d pi equal to 3.14. Okay, see here, hyphen d and pi is the macro inside, and this is the value. So similar to this notation -d_name equal to value, right? Yeah. Let's do that. Let's see. Okay. We have compiled it 2017, and let's see what does it have. See here. Okay. So instead of defining it here, you can send that from command line directly. Okay. From command line directly, right? Yeah, here from command line directly. Okay. For example, tomorrow, if you want to change this value, you don't need to change in the C file. You can directly provide here. Let's say 3.141. Okay. 3.141. And it got compiled. See here. So this is 78.5. This is 78.52505 something else. And this is 31.4. And this is 31.414. The circumference is. Okay. So this way you can, macros are very useful. Macros are very useful, very customized, right? Very customized. If I want to find the radius, want to find the area of a circle or circumference of a circle, then my value, that formula or maybe the area and circumference depends upon the precision of pi value, right? That we can alter, or that we can change from the command line directly. So which is very very convenient for us, right? Okay. If you want 3.14 for 2 decimals, you can write. So based upon the precision requirements for you, okay, you can do that. So macros are very useful in that front, right? And also along with these things, right? So we have hash pragma, preprocessor directive, hash error, hash warning, hash undef. So these are the things that are available. So hash undef pi, for example, you have let's see, so you have defined this here, and somewhere in the code, if you want to undefine, then you can undefine, which means that the pi value is not available now. Okay. Undefined means the pi value is not available after the statement. For example, here you have defined, and if you come here and then write hash undefined pi, then the pi value will be, it will forget about the pi value, that is undefined. The definition is removed. Okay. Good. So hash error and hash warning are useful in the compiler, for compiler actually. For example, in the while compiling your code, if you want to add your custom error message and warning message, then these are very useful. These are very useful. Okay. So this is about macros. Macros, we can talk about many things actually. Macros are very beautiful to discuss and very beautiful to write in our programs. Okay. So we can, whenever it is possible for us, then we'll just touch upon those macros, and also here hash if and all this stuff I'll explain to you, because going forward, like we are just touching upon basic concepts, and then we are learning step by step. Okay, I'm not going into the complicated software design yet. Okay, so we'll just go smooth, we'll go slow, and we'll understand everything, and we'll touch upon all the aspects of writing very good C program. Okay, right. Let's hear, I will after discussing this one, I'll stop here. So here I told you about functions, right? Functions, right? So these are the functions that we have created. Functions are very useful for modular programming. And yeah, so here we are using, there are two types of calling a function. There are two types of calling a function, pass by value and pass by reference. So what is pass by reference? That I will tell you in the upcoming class. When I am talking to you about memory, then I will touch upon what is pass by reference. For now, what we are using is pass by value. I will explain that. What is pass by value function calling? Okay. So here at line number 26, right? So you are calling area of a circle function. Then the flow comes here and suddenly it jumps to area of a circle. Suddenly it jumps to area of a circle and then it will perform these operations. Okay, right. So here we have an argument radius, right? We have an argument radius. We are this radius is, what is the value of radius? Value is 5. Then this radius value will be sent to this area of a circle definition. Okay, send to this function. Okay, right. And here a copy is maintained. Okay, whenever you see this radius, the radius is sent to the value, actual values copied to the function definition, copied to the function definition. That is what we call pass by value. Pass by value. It just sends the value. Okay, it just sends the value to this function. Okay, this is pass by value. And there is one more thing, pass by reference. We will look at that in the upcoming classes. Okay, so for now I'll close and we can go for Q&A sessions. Before that, I'll open last assignments solutions. Okay. Yeah, so these are the questions that we have. Only 4 questions, 5 questions I have given to you. So let's look at what are these questions. I have asked you for theory, what do curly braces denote in C? Why does it make sense to use curly braces to surround the body of a function? Okay, body of a function. So the simple thing is the curly braces defines the scope of the function. The scope of the function. Okay, in that scope, whatever you have defined in that scope, they are available only in that scope. Only in that scope. Okay, let's look at the answer. So the curly braces denote basically a block of code, and in which the block of code the values are declared. And variables whatever declared in this scope, right, they are available only till that end of the right curly brace. Okay, that is what we call scope. So the space between the two curly braces, the left and right, is what we call scope. Okay, so the body of a function is one such type of block. Basically the body of a function is also a type of that block. Okay, and thus these curly braces are used to describe the extent of a block. How extent this block is. How extent this block is. Okay, and this I have not given you. So this I have given you to rewrite this so that we will get answer 11.0. Okay, so this is the answer. This is the answer. Okay, using braces, brackets, you can modify this expression so that you will get answer as 11. Answer as 11. See here, so 10 plus 2, and if you just write a open bracket here and here, just subtracting from 3 to 3, 3 minus 2, and then multiplying with 2.0. Okay, and the whole thing is divided by 2.0, right? Then this whole thing comes down to 1 and added to 10, which is 11. Okay, so otherwise if you just look at here, see 3.0 and 2 into 2. Simply this is 2 into 2. Okay, first the execution starts here. Means first this is evaluated. Okay, 4 and next 2 by 3 and the subtraction happens and adds to 10. Okay, so which we don't get some integer value. Okay, right. So excuse me. So in order to write, um, make this to get a desired value, so we use brackets and all. So the arithmetic expressions, their associativity and precedence, we'll talk. I want to complete today, but I couldn't do it. We can do it in the next class. And now write a function to do the square operation, to do the square operation. So simply you can just return in your function x by x. Okay, this is using macros. So I asked you to write a function basically to do the square operation. So you just define your function uh, to return the square, So just return x into x, or return whatever the variable that you want multiplied by the same variable. Okay, right. The next question is, yeah, so I asked you to just rewrite the program, hello learners program, and compile and execute, and print the same thing on the console. Okay, so what is the command you should use, and what is the output of a program? So gcc and then source file -o and the executable name. Okay, output of a program is same, hello learners, right? Yeah, so this one I have given I have used some macro here, one macro here. So I want you to just rearrange these steps, these 6 steps, so that it gets a meaning, Let's check out this. Yeah, see here. So this is the rearrangement. Okay, first comes the hash include, and what's next? Any other defines, right? Any other defines, and our main starts, and our variables. Okay, next puts message. Puts means something like printf. Okay, it puts the content on the console. Okay, and we return, and after that we'll close the bracket. Okay, so these are the sequence. This is the sequence of steps, right? And here to these below statements, I asked you if they are correct or not correct, explain. They're correct or not correct, explain. So is this correct? Hash include stdio.h. Hash include stdio.h. Is this correct? And there is a dot here. Okay, it's not correct, right? So dot should not be there. The dot should not be there. So this statement don't end with dot. Okay, right. And see here, int function and return arg1 minus 1. So here what is the error here? The error is here. See, in data types, I forgot to tell you that there is another data type called void. Void means nothing, means it is not of any type. It's you can think of it like in a raw memory or something like that. It's not defined. Okay, so void, and it is taking void as the argument. And so you're trying to do so subtracting 1 from the arg1. Okay, then it errors out because void doesn't define float or integer or whatever. So you cannot do arithmetic operations on it. So that's why it will error out. So before doing any arithmetic operation on it, you need to convert this void type to integer or float, whatever. Integer or float, whatever types, you need to do that, right? Yeah. So the void type is empty variable basically. Okay, we can think of, and this doesn't okay, this doesn't this doesn't signify any particular number type. So that's why it fails. The correct thing is, you can just simply instead of void, you can use int, or you can convert this void type into integer or floating, whatever you want. Okay, right. So these are the things that I have given you in the previous assignment. Okay. Yeah. Okay. We are done. If you have any Q&A session, I have any questions, then please let us know so that we can answer your questions. Any questions you have? Otherwise, we can wind up the meeting. Please let us know if you have any questions. Otherwise, we can wind up the meeting. Okay, fine. I think you are, sorry, let me give you that access. You can unmute and you can start your, okay. Okay, any questions? If you don't have any questions, then we can stop here, and we'll meet in the next class. Okay. Over to Anand, brother.
Okay, thank you, sir, for explaining very clearly. Yeah, I hope our friends will understand the class. So, dear friends, regularly join this class on time and kindly follow the guidelines and instructions and tips which are going to be given in our WhatsApp group. Kindly check our WhatsApp group once in a while, so we'll get the updates. Thank you for joining. We request to join regularly. This is a very important course for you. Don't think that it is freely, so don't take it lightly. We are doing as a part of social service for your benefit. Kindly make use of it. Thank you.
Thank you.
Thank you, sir, once again. God bless you all. All glory to God alone. Take care. Bye-bye.
Bye.